Hi, my name is Valery Markin and welcome to the session with a specialist. Today our guest is Hertogs. Uh, Welcome. He's manager operations at Infraspeed, and Infraspeed is owner and maintenance company of high-speed line in the Netherlands. And the topic of our talk today is maintenance of high-speed lines. But before talk about maintenance, let's talk about the features of high-speed lines. What are the specific problems? What makes it different from the normal track?
Yes, the difference between the high-speed line in the Netherlands and the other tracks in the Netherlands is that the high-speed line south, which is maintained by Infraspeed Maintenance BV, has slab track. That means it has concrete track and for a speed of 300 km per hour. Also ballast track. And other difference are the 25 kilovolt catenary, the catenary system 25 kilovolt and ATMS system level 1 and level 2. That are the main difference between the high-speed line and the conventional track in the Netherlands.
Right. And the problem which occurred during the time during the operational period of the track, are they a bit different or the same as the
Yes, there are some differences. The line was newly built. It is a complete new line, finished construction in 2006. After that, we are doing for 25 years the maintenance of the high-speed line south. And in the beginning of a new line, you always have child diseases, and that means that you, with new equipment, the first years you have different kind of problems with new equipment. Another type of problem we have is things like damage on the rails. There are different types of rails used than in the normal line, and also the operations of the line is a little bit different from conventional track. That has been mitigated, so that's at the moment it's under control. Mm-hmm. Other differences are problems are we have settlements in the substructure. High-speed track is of high accuracy. That means its accuracy is within millimeters, mm-hmm. And that means if you have settlements of the substructure, then you have a risk with for derailment. So we have to correct the track.
But I can imagine that concrete slab is not very easy to correct. It's not like a ballast.
You have to
lift the track on
you have to correct the rails. So that means that you can correct the rails to, let's say, 54 millimeters and in height, and then of course
laterally you can also
laterally you can have some millimeters of space to correct it, right. Up to 8 millimeter. So there is some correction possible in lateral direction and vertical direction, but of course you should. What we are doing now is try to prevent that there are bigger settlements than this correction possibilities in let's say the rail fastening system. So that's what we are trying to mitigate at the moment. Other subjects for the high-speed lines is that at the moment there's a bridge in the south of Holland. There's a lot of wind on this bridge, and it means that the new type of trains which are coming in 2020, they drive quite fast, and there's a lot of wind, and that means that there will be windscreens on the bridge. That is planned at the moment to build windscreen on the bridge, that these trains can drive also with strong winds, 200 km per hour.
Yeah, of course. And the rail, what kind of a problem can we expect on the rail?
With the rails, we have head-hardened rails, and the head-hardened rails, there has to be some wear of the rails so that you don't have cracks. And the maintenance has to, of course, always has to be done properly according to the standards. We do that, and the only thing is that we have rolling stock which is driving a little bit slower than expected, and it means you have different type of loads on the rails, and this means also that you then have a different kind of rolling stock, that we have some additional maintenance to do to correct the rails and to avoid cracks in the rails.
Yeah, but I can imagine that if something wrong with the rails with the high speed, the problems can be much severe.
Yes.
And
Yes, that means if you have for a high-speed line, the crack depth, by example, in our case, is a maximum of 10 millimeters. That means that if you have we measure the rails with eddy current and with ultrasonic measurement equipment, and that means as soon as we see small cracks from 1 to 3 millimeter, we also already start to grind the rails. Of course, we have also some cyclic grinding up to 0.2, 0.23 millimeter. With deeper cracks, we correct the rails, we do some corrective grinding, or we do some rail replacements. But with a high-speed line, you always have to be very careful that you don't have deeper cracks, that you have rail breaks, because with a rail break with a train with 300 km/h, that is really something you want to avoid, of course. And that is, for a safety point of view, very essential for a high-speed line. For low-speed lines, is a rail break also not. You also don't want a rail break with lower speeds, but the impact is much greater if you drive 300 km/h.
Yeah, but since we already started to talk about maintenance, when you perform maintenance on high-speed truck, I can imagine that there are some difficulties, because as far as I know, you have very strict availability requirements
Yes.
for high-speed line.
Yes, the availability requirement is very high. That means that during the time the trains ride on the line, that's some 18 hours a day, we have to guarantee an availability of the line above 99%. And to have this high availability during the construction phase, a lot of systems were made redundant. That means that if a system fails, another system takes over, mostly computer systems. The main risk for non-availability comes from switches and from the catenary system. You cannot make switches redundant, and you cannot make the contact wire or the catenary system redundant.
But switches, do we need to connect to conventional line, or do you have also switches for?
We have switches to the conventional line, and of course we have high-speed switches in the line.
In the line as well. Okay.
In the line itself, there are high-speed switches, and for different speeds. But the switches are the most vulnerable part of a high-speed line. So non-availability is mostly due to a failure in the switch, or the catenary system that breaks. So the main risk for our high-speed line is failure in switches or breaking of the catenary system. Other systems like power stations and tunnel technical equipment or signaling system, they are mostly redundant, and that means if there is a failure, we get the information that there is a failure, but that doesn't influence the operations of the trains, and it means we can correct the failure during a possession in the nighttime or other times, but you have time to then correct the failure because another computer system takes over, and that makes the whole line, that gives the line a very high availability. So you're dependent on a good design, a redundant design, and good maintenance, and that together can bring availabilities above 99%.
Yeah. Well, and the organizational part of this process, the maintenance,
Yeah.
do you do it yourself or do you delegate it to contractors?
We are ourselves are the asset manager and the maintenance manager, and we also do the operational part, so the maintenance itself, but of course together with different maintenance companies. So we have sub-suppliers who support us, but we are lucky that we have the asset management, maintenance management, and operations in one hand, and that makes it more easier to stay in control, to have this high availability.
Because you have your own quality requests, I think.
Yeah,
as well.
your own quality requirements, and it's very important to have a good maintenance organization. We have, of course, well-educated people. You have to have well-educated people. You have to look very carefully at your spare parts, that you always have spare parts available. So that's very critical. Education I've mentioned, they have to have the right information, the right tooling, and of course they have to be flexible. Every day of the week there have to be people available to repair if there's a failure in the track.
Right.
Yeah. So these are the main features. Is how do you get a high available line, good design, high standards for maintenance, well educated people, right spare parts, right tooling, right education, and then you have a good you have a good environment where you can have a high safety. Safety is one, and then availability. Our whole organization is focused on one, safety, two, availability. Third place is compliancy with the law and the contract, of course. And finally, if you have high safety, high availability, you're compliant with your contract and the law, then you can start earning money. And that's in that sequence you have to do your maintenance. So safety is really number one, because if you're on a high-speed line with 300 km per hour, you always have to avoid a risk on derailment. That is very, very important.
Right. Well, in this course we talk about not only maintenance, but we talk about how improve the maintenance, and we talk about smart maintenance. So my question is, what do you do in your company and with the maintenance of high-speed line in this respect? How smart is your maintenance?
Yes, what in our case is very important is that to have sufficient data, what of operational data and maintenance data. Data is very important nowadays in the different companies. Also in our case, that is also due to the contract. We have to prove that if there is a failure on the line, that is not because of us. So we collect a lot of data. We know exactly how our assets are behaving. So if there is a failure in a switch, we see it in a monitoring center. We collect the data of this monitoring center at this monitoring center. The data goes to our maintenance engineers, and our maintenance engineer look at every failure that's occurring in the line. So what we do is that we look at every failure, and we also try to avoid failures that we can predict when a failure could happen. So we do also predictive maintenance. That means we see a lot of data of switches of the catenary system. By example, we also measure currents from the power stations to the line. We know every train movement. So if there is a failure, we can analyze where's the failure coming from. And then if it's a systematic failure, so if you see a failure occurring often, then we try to optimize or our maintenance, or we replace the assets or renew the assets. We make a technical change.
Improve the design. Yes.
Improve the design.
Yeah.
So the thing we do is look at every failure, try to collect as much data as possible.
Talking about data, sorry, I can interrupt you. Do you get it from the train, or you measure it from the track itself?
We have different sources of data. We do a lot of measurement also with trains. We have companies with measurement trains. We measure the track geometry. We measure we have ultrasonic measurements of the rails. We have eddy current measurements. We measure on the catenary system. We try to introduce also some new technology, but also our own systems. From the switches, we have the different. We have a roadmaster system where we collect data from the switches, so the forces, the currents in the point machines. We have data from the tunnel technical equipment constantly. The signaling system gives error data. The power stations have error data. And also we measure currents to the track, so we can exactly see how much current is there going to the track, and we can combine it with the data where are the trains driving. So if you have a short circuit in the catenary system, we can combine measurements of currents and locations of trains, where we can see is there a train causing a short circuit, or is there something else going on.
Yeah.
So data can come from many sources. Also our maintenance management system, of course. Our service personnel, our inspectors, they collect data, they put it in the maintenance management system, and from all these sources, trains, data from the technical equipment, maintenance management system, the signaling system with the GSMR data from the ERTMS system, we also collect this data. All this data together is in one assurance database, and from this assurance database we can analyze this data and see where our faults or failures coming from, and how can we optimize our maintenance. A second database we have is irises from a company called Edmond, and this irises database all our measurements from the trains, track geometry, catenary system, but also georadar, all these noise measurements, all this data is in one database with a linear location, so it's along the line, of course, and you can also analyze linear data along the line in this ERISIS database. So we have two big databases, assurance database, ERISIS database, where we collect all this data, and a maintenance management system, and our maintenance engineers are doing some analysis on it to optimize maintenance,
Right.
and to reduce failures, of course.
Right. Well, it looks like many contractors and many maintenance organizations or infrastructure providers in our country and worldwide are busy with this creation of this smart maintenance system. So in this respect, I just wonder, do you cooperate with other companies, infrastructure managers, other countries?
We have close contact to ProRail in Holland. They are the biggest asset manager for the conventional track, and we have good contact with them, so we exchange information. We have a lot of companies in the Netherlands who bring in new technology and advice to us, and consultancy where they give opportunities to optimize our maintenance. By example, we have a company optimizing our spare parts. We have a company optimizing our asset management system. We have companies looking at maintenance. We have companies who advise us on data science. So there are many companies who can help you to improve your maintenance and look at new ways to that. One important improvement where we're working on now is that you look at your processes, and you have defined in your quality management system, you have defined your processes. These processes are mostly also in your maintenance management system, and there's a lot of data in the maintenance management system, and what we try to do is analyze these processes from the data in the maintenance management system and look where our optimizations of our maintenance system is possible and our maintenance ourselves. So with data science, you can check your processes. Are the processes according to your quality management system? And do you see repeatments in your processes? Do you start working on a step in the process again and again? Is there some lean maintenance possible there? So lean maintenance is of course very important. How can you reduce the number of steps? How can you do it first time right? And all these things, all this data helps you to go to lean maintenance and optimize your maintenance.
Yeah. Well, thank you Art very much for a very interesting talk, very interesting story about the HSL high-speed line, how it operates, what kind of problem occur, and what you have to do in order to maintain it very well. So thanks a lot.
Thank you very much.
Again. Yeah. And see you next time in our session interview with specialists.